Hi guys, I am here to show you how to measure sperm using ImageJ. So, what we're going to do first is download it. We have it on the computers in the lab, but in the event that you are so into measuring sperm and you don't want to stop, then you can download ImageJ onto your own computer at home and work on it whenever you want. Yay! Alright, so what I'm going to do is I'm just going to Google ImageJ. And helps if I spell it right. Alright, so I'll hit the download. And this is free software that is downloadable from an NIH website. So depending on what kind of computer that you have, you can download whichever one is appropriate. I have 64-bit Windows, but I download the 32-bit Java because I don't actually need a 64-bit. And so I've already downloaded it and I have saved it into, I'm on a PC, so I've saved it onto my quick start menu down at the bottom so I can easily access it. Let me just kind of go through the process a little bit just to show you what it looks like. So you just basically download it onto wherever I like to put mine in downloads, and it already exists. Sure, I'll replace it. And then you can just basically click on this and it'll start and run it, and it will start your setup. So I'm going to get out of that and open up ImageJ. So you will be accessing image files from Dropbox or some other folder. And once you open ImageJ, this is what it looks like. This is all it is. It's very simple. The first thing you want to do is open an image file. And so I've got a couple on my desktop that I'm going to open up. And so the next thing that we need to do is set the scale. So we go to Analyze and Set Scale. I'm going to click on that. And we generally take images at 20x, and at that magnification we are going to be at 3.06 pixels per micron, so per 1 micron, and we'll put micron here, and that's now our scale. And we're going to click global because we want this to be true of all of the images that we're processing. If by some chance you forget to set the scale, or you realize later that, oh my gosh, this sperm was actually imaged at 40x, then that's okay, don't panic. You can still use those measurements, we just need to convert them appropriately. Okay, so now we've set the scale, so we're ready to measure. So what we want to do is use the segmented measuring tool, and we're going to hover over this guy, and I'm going to right click on this button, and I'll choose segmented line. So now it's segmented. Now this is actually a fairly clear image of a sperm, and what we're going to be doing is I'm going to zoom in, and I'm going to actually make this smaller and then zoom in, and I'm doing this, what I'm doing is I'm going to hover, I'm going to make this a bit bigger, and I'm, there we go, and I'm hovering the mouse over where I want to zoom into, and then I hit the key that has an equal and a plus sign on it to zoom in, and then where my mouse is, that's where it moves to, that becomes the center. Now, in order to zoom out, I am hitting the key with the minus and the underscore. So imagine minus means that you're zooming out, plus means that you're zooming in. Okay, so now I'm zooming out. And again, wherever my mouse happens to be, that will become the center, more or less, of what you're zooming in or out of. So in order to do this, what we're going to do is start, here's an arrow. There may or may not always be an arrow pointing to where the head end is, but in this case there is, and what we're going to do is start at the head end. It doesn't actually matter where you start, but we're going to start here just because we can, and I'm zooming in focusing on this. And so I'm going to make it fairly big so that it becomes pixelated. And I'm going to estimate, I'm going to start around here because that seems to be where the tip of the sperm head is. And I'm going to just follow it around. And I'm actually thinking that this is a bubble. This is not actually part of the sperm. All right, so I'm going to start here. So there's going to be, I'm going to zoom out a little bit. The first thing that you want to do is kind of get a good picture of it. There's going to be a lot of stuff like this where you have to really think about where the sperm is going and try to follow it as best you can. One way, different people might have different ways of that they prefer to think about it. I like to, when I see a region like this, where I'm going to zoom in on it, where you want to make sure that you're following the right path. I think of it like intersections or like slicing a pie. And the middle of the pie is, say, here, and you want to make sure that it looks like it was sliced appropriately. And so I can see that this line continues this way rather than continuing this way. And so it's going to continue this way and then keep going up. So you want to follow and maintain the same direction each time. So so I like to get a view of the entire sperm before I really even get started, so I'm not moving along and then suddenly I get to an area where I have no idea what's going on. So I want to be able to figure it out before I get started. In the event that you don't figure it out before you get started, that's okay, because as I'll show you in a little bit, you can actually create, you can measure different segments of the sperm and then add them up to get the same thing. So if you're not sure which way it goes, you can take different measurements of different sections and then add them together, and that's fine. All right, so to get started, I'm going to kind of navigate my way back to the head, and I do this by zooming in, zooming out, zooming in, zooming out to move the image where I want it to be and make it at the right magnification that I want it to be. So I'm going to start here, and every time I click with the segmented line tool, every time I click, it's going to create a little segment. And this allows me to follow the path of the sperm. And I want to do it as, reasonably close as I can. So I don't want to have a lot of straight lines like that. I would rather have it more frequent segment points put down so that it more closely follows, just for the sake of accuracy. And so once I reach the end of the screen, I'm going to zoom out, hit the minus key, and then zoom back in, and keep going. All right, so when I get, so this, takes a certain amount of time. The other thing, so when you're done measuring, you double click. Sometimes you double click by accident. If you didn't move, if you're going quickly and you didn't move the mouse far enough, the program might interpret that as a double click. And in which case your segment is done. Don't fret. You can take that measurement and then keep going from that point and add it together. So let's just say I stop here. I can hit Control M. So I'm going to move this. I'm going to go over here and I'm going to hit Analyze. Measure is what we want, which is also called Control M. That's the shortcut key, and the length that we have is 276 microns because we've set the scale already. And so that's our first measurement. If we wanted to start again at this point, I could click, keep my eye on it, I could click outside of here and then click here again and then just keep going and take another measurement that way. And so you can, I would rather you not do that, but if you have to, it's not the end of the world, and so you don't have to go back, because it does take a while to kind of measure the entire length of these guys. Something you can do while you're listening to the radio or watching TV or listening to TV. So let's say I'm doing another measurement. Now it's added on here. Now once we have a number of measurements, we can actually save as an Excel file. All right, so you want to save it as whatever. I don't know if we have a system yet for actually naming things yet, but I do know that you can save them as an Excel file and then copy and paste them into a master data sheet, which Sarah has told you about or will tell you about. All right, so I'm just gonna cancel that. All right, so let me just zoom out. Whoops, let me get rid of that. So you're basically gonna do it, and when you're done, you're gonna double click, and that will be your sperm. There are times where you get some less clear images. So I'm just going to open up another one that may be a little bit less clear. So sometimes there's some craziness going on up here, or there may be part of the sperm that's obscured. You want to put that in the notes of the master sheet, just to make sure that we know that there may have been some difficulties. So for example here, I think that this sperm is generally not a full-length sperm anyway. And you'll get, because the sperm are so long, sometimes it's tricky to tell whether a sperm is broken or not, because they look so long. So it looks like the whole thing is there, and then you measure it and you're actually missing a couple hundred microns. There's nothing you can do about that. You just have to kind of know that, okay, I need to measure at least one more sperm to make up for that one, because we can't use that data point. So for cases like this, where you really don't know what's going on in here, I would not use that sperm. This one, on the other hand, I think you can use. I have a feeling that this one is actually too short, but because I think I've measured it before. But yeah, so that's generally what needs to be done, and how you do it and how you save the data file. And once you're done with an image, you can just close it and move on to the next. I like to only have one image open at a time, so that the data don't get confused with anything else. But that's just me. So, all right, I hope that was clear, and if you guys have any questions, you can ask me or Sarah. Thanks.